Hi, everybody. Next time I see you, we will be having a quiz, as you know. So we're going to practice the quiz type problems first, but then we have to do some general review because we have a test coming up. I believe it'll be next Thursday. So we don't have any class periods between then and now. So let's make the most of this time together. So I have put together some problems here. These are nowhere. These are just random problems I made up to practice this type of problem because this is going to be on our quiz. So you might want to just do this on a sheet of paper, or I don't know, whatever works for you. Here we go. So sine 53, so I'm going to leave the numbers out. Sine cosine plus cosine sine. Got your reference sheet handy. That is a formula for the sine of u plus v. U plus v. So that's going to be the sine of 63. 53 is u, 10 is v. I'm adding them together, sine 63. All right, this one, 1 plus cosine divided by 2, all under a radical. That is the formula for the cosine of x over 2. So the cosine of half the angle, so cosine 6. That's the formula for the cosine of 6. 1 minus 2 sine squared. 1 minus 2 sine squared is one of the cosine formulas for the double angle. And this is double 72, so this will be the cosine of 144. We have to get comfortable with our reference sheet, find these formulas, and apply them. All right, tan plus tan over 1 minus tan tan. That is the formula for the tangent of an angle plus an angle, u plus v. So what is that, 71? 52 plus 19. And finally, this guy, be careful. Think tattoo. This is sine squared plus cosine squared, and it doesn't matter what these are as long as they're the same thing. If that's a 48, that's got to be a 48. But as long as they're the same thing, sine squared plus cosine squared is always going to be 1. Always going to be 1. So on our quick quiz, and this will be a quick quiz, we're not going to spend a ton of time on it. You are going to have some problems like this, okay? We already talked about this. You're also going to have a problem like the cosine of 285. Now, this one, I am going to get a couple problems from in my review packet, the back of page 6. We did the front in class together, but now we're going to look at the back of page 6. And the first problem is going to be a quiz type problem, cosine 285. So what you're going to do is you are going to think of two angles that you can, two of your special angles, that you can add or subtract to get 285. Now, you're not here with me, so I have no idea what you are shouting out right now. There are lots and lots of options. I'm going to go with 240 plus 45. I told you today that anytime my angle ends in 5, I am thinking about using 45. And so if I use 45, then I need 240. 240 is on my list. You remember that 240, I'm going to erase all these, 240 is the third quadrant 60-degree angle. If I draw 240, here's 180, here's 270, here's 240. That's a 60-degree angle down there in quadrant 3. That's why it's special. It's a 60. Remember, there's a 60 in every quadrant. There's a 30 in every quadrant. There's a 45 in every quadrant. You have those numbers written down on your sheet, or at least you could. And those are the angles that we're using when we have to find the cosine of something like 285. Okay, so what's the formula for the cosine of 240 plus 45? Cosine 240, cosine 45, minus sine 240, sine 45. So cosine u plus v. Cosine u, cosine v, minus sine u, sine v. All right, let's start plugging in numbers. Now, 45s, remember, those are the ones that match. So the cosine and sine of 45 are both root 2 over 2. We don't need to worry about that. It's in quadrant 1, 45, so they're both positive. And technically they're 1 over root 2, but we're rationalizing it. So it's root 2 over 2. Now, what about 240? Well, I have my picture over here. I know that with a 60, this is going to be root 3, 1 and 2. Those are the sides. Be careful. I noticed in a lot of your homework, we're not paying attention to the quadrant we're in. This angle has 2 negative sides. So when I go to fill in the cosine of 240, it's going to be negative 1/2. And when I fill in the sine of 240, it's going to be negative root 3 over 2. So I have negative root 2 over 4 minus plus negative negative plus root 6 over 4. And there is my answer. That's what I will write down. Make it one fraction, put it all over 4. This is 4. It looks like all the others. Yeah, it does, because we keep using the same numbers. It's all root 3 over 2, 1/2, root 2 over 2. That's all we use. All right, so that's going to be another quiz type problem. And the third quiz type problem, and again, I'm on the back of page 6. The third quiz type problem is number 3. Where you're going to have to do a simple verification. Now, this isn't a verification, but it is the kind of problem you're going to do. We're going to figure out what this equals. We're going to simplify it. So this is the cosine of u minus v. So that's going to be cosine 270 cosine x plus sine 270 sine x. Cosine cosine plus sine sine. Okay, now let's look at 270. Here's 270. Straight down. Cosine is x, and x is 0, so this is 0. 0 times cosine. 0 times cosine, which, oh, by the way, is just 0. Plus, all right, sine 270. Sine 270 is negative 1 times sine. So that's just going to be negative sine x. Okay. Now, we're going to go ahead and finish this sheet. The rest of these problems will be on your test, but not on the quiz. The quiz is just those 3 that I just went over with you. We did the same 3, or same kind of 3, in class. So if you're confused, you can watch that video, watch this video. You'll know exactly what you're doing. On our quick quiz, be very quick, on Tuesday. You need to practice so you know what you're doing. You're not going to have time to sit there and ponder and experiment and everything else. We got to boom, boom, boom. All right. Okay, now that was number 1 and 3 we've already done on the back of page 6. Now I'm going to do problem 2. So I am given that sine x is negative 4/5, and I am between 180 and 270. And I am going to find the tangent of 2x. Please do not make this hard. It is super simple. What is the formula for tan 2x? 2 tan over 1 minus tan squared. Now draw a picture of what you know. You know that the angle is in quadrant 3, 180 to 270. You know that its opposite over hypotenuse is -4/5. We can do the Pythagorean theorem. Oops, I'm giving it away here. I don't need the negative because I'm squaring it out anyway. So x squared plus 16 equals 25, x squared equals 9, and x either equals 3 or -3. Now, most of you already knew that because 3, 4, 5 is a triangle we use a lot. It's a Pythagorean triple. But here's the work that goes into that if you don't just know. I need -3 because I am, after all, in quadrant 3, and x is negative in quadrant 3. Okay, got my formula. I'm going to look at my picture and I'm going to plug the numbers in. So 2 times the tangent. The tangent is 4/3. Opposite over adjacent, negatives cancel. Over 1 minus 4/3 squared. So 2 times 4/3 over 1 minus 4/3 squared. All right, let's do the arithmetic. So on top, I have 8/3. And on the bottom, I have 1 minus 16/9. This is 2 over 1 times 4 over 3. That's 8/3. 1 minus 16/9. So now I'm going to multiply everything. You can do this however you like. I'm going to multiply everything by 9. That's going to cancel this denominator and make 24 on top. Because when I cancel 3 into 9, I have 3 left, times 8. Down here I have 9 minus 16. Again, I don't care how you deal with that, but you're going to have to deal with it and end up with -24/7 as your answer. That works best for me. But you might want to go ahead and subtract these and then keep, change, flip. Up to you. Answer's the same. You got to be able to come up with that answer. All right, and then number 4. It's a very, very similar problem. Number 4. The given, I'm just going to draw it. Where am I drawing my given in problem number 4? Notice it says x is between 270 and 360. So that means quadrant 4. 270, 360. And opposite over hypotenuse is -5/13. Now again, I got the same situation. This is another special triangle, Pythagorean triple. But if you don't recognize it, you're going to do this process. So you're going to do x squared plus 5 squared equals 13 squared. Again, the negative doesn't matter because you're squaring it. X squared plus 25 equals 169. X squared equals 144. So x is 12. And it is positive this time. Look where it is. Going right. That's a positive. So that's a picture of what they gave me. Now I am supposed to be finding the cosine of x over 2. So the first thing I do is write down my formula. Plus or minus 1 plus square root, 1 plus cosine over 2. That whole thing is under the radical. Now I'll look at my picture, and I'm going to plug in the cosine. So looking at my picture, it looks like 12/13. So all I do is plug from my picture, plug my cosine value into my formula. Now again, that needs to be cleaned up. I will clean it up by timesing by 13. But you can do it other ways. I end up with 13 plus 12 over 26. So I end up with 25 over 26, the square root of 25 over 26, which is 5 over root 26, the square root over the square root, so 5 over root 26, and then I'll rationalize. So finally, I'm going to end up with plus or minus 5 root 26 over 26. Now, if there's something going on here arithmetic-wise that you don't know, I would say office hours would be a good time to handle that on Monday. Now, the only thing left is to figure out, I got my number. I need to figure out, is this going to be positive or negative? And we talked about this a little bit today earlier. This is tricky because you have to remember that X, this was written down, X is between 270 and 360. But your problem is half of that. So you got to cut this domain in half. So where is that X over 2? Well, it's between 135 and 180, which means that angle is over here in quadrant 2. Okay? And in quadrant 2, the cosine is negative. So this is going to be, you're going to want the negative root. So when you go to pick your plus or minus, you base it on the half, not the whole, the half. The whole angle was in quadrant 4. Half of it ends up in quadrant 2. Okay, now we are going to go to page, just a minute, I'll let you know. And we're going to go to the back of page 4. We're going to the back of page 4. Okay, so here we are on the back of page 4. The first one is just a little algebra practice. It does not have anything, well, sort of does. I mean, it's a complex fraction, I guess. But this is not trigonometry. This is just, can you simplify that? And I hope we've done enough of them that you are comfortable looking at that and saying, hey, I can fix that. All I have to do is multiply everything by x. Because x is the denominator, the common denominator of the denominators of all 4 pieces of the problem. X is actually the only denominator. So I'm going to end up with 2x squared plus yx. Now these cancel, that's why you did it. So you have 1 plus y squared x, and you're done. That's all there is to it. There could be a situation where after you did that, you notice that you could cancel something, but here we can't. So we're done. That's it. That's it. Okay. Number 2, we're going to do some proofs. All right, so here we go. These are so much more fun when we're together, so I can hear your ideas, because I'm sure some of you have some really great ideas. And some of you are sitting there like, what's going on? Okay, we got a secant in this problem. I look at it, and I know I'm supposed to end up with secants, but I got a secant over here. Maybe I can handle it that way. How about doing this? Since I want to end up with a secant, what if I changed my cosine into 1 over secant? That's what it is. If that isn't written on your paper, go ahead and write it down. We know that 1 over cosine is secant, so 1 over secant is cosine. They are reciprocals. Now look at that mess right there. That is a complex fraction. What is our, just like that one right there, our only denominator is secant, so let's multiply everything by secant. And that cancels those out, which is exactly what I wanted to have happen. So now on top, I have secant plus secant squared. And on the bottom, I have 1 plus secant. Keep your eyes open. Look on top. What can I do up there? I can factor out a secant. Now some of you might be thinking, oh, secant squared, that's 1 plus tangent squared. Yeah, but I don't want to do that. I want to be a secant. I do not want to be a tangent. So I'm going to take a secant out of that. And that will leave me with 1 plus secant. If I pull a secant out of my numerator, and lo and behold, what's on the bottom? And we're left with secant, which is exactly what we wanted to be left with. Okay. Next. Just like this problem that I'm erasing right now, I chose to start by changing my cosine, my cosine into 1 over secant. And my logic was, my goal was to end up with all secants, just secant. So why not change right from the beginning and get secants to work with? So the whole problem was secants, and then things could cancel and whatever. Well, B is kind of the same thing. And again, if you don't like the thetas, change them, people. I'm not changing them, but you can, doesn't matter, change them if you want. I need everything in this problem to cancel out and leave me with 1, right? So how about if we changed our sine squareds into cosines? We can do that because on your paper, you have written that 1 minus cosine squared is sine squared. And if you don't have that written, you absolutely should. We use it a lot. So this sine squared, I'm going to replace it with 1 minus cosine squared. Okay, that's not a divided by, changing them. And then I'm going to do the same thing here. So this is 1 minus cosine squared, but this one is times a cosine squared. So again, I'm looking at where I'm going. I'm going to 1. That means everything has to cancel out, basically. So things don't cancel unless they're the same. So I'm going to change them all into cosines. Could I have changed them all into sines? Yeah, that's a little trickier because that's a fourth. There aren't any formulas for fourths, so you have to deal with it. So I just said I'm going to stick with the squareds because I know those are both 1 minus cosine squared. Okay, So what have I got? 1 minus cosine squared plus, all right, now distribute. So that's going to be cosine squared minus cosine to the fourth. I'm distributing plus cosine to the fourth. Oh my golly, what happens, you guys? These guys cancel, and what am I left with? 1, 1. Okay, now I've got sine squared plus tangent squared plus cosine squared equals secant squared. If you say that problem out loud, something will occur to you. Sine squared plus tangent squared plus cosine squared. Sine squared plus cosine squared is 1. And 1 plus tangent squared is secant squared. Done. Done. So easy if you pay attention to your identities. Your formulas on your reference sheet. All right, one more. We got tangent plus cosine over 1 minus sine, and that's supposed to equal secant. Okay, this is a mess. Again, I wish we were together. I'm hoping you're thinking, there's no, sine squared and cosine squared and 1 plus tan. None of that's going on in this problem. So I'm just going to change that tangent into sine over cosine. Please don't try anything tricky with 1 minus sine. It's not squared. And if it's not squared, you don't have an identity for it. So don't. You can't. But now, I do have 2 fractions, don't I? I have 2 fractions that need to be added together. Right? So let's get a common denominator. Let's multiply this one by 1 minus sine. And this one by cosine. Because that's what we do, kids, when we add fractions. We get a common denominator. And that common denominator is 1 minus sine times cosine. Now what's in the numerator? Let's look at it. What's it say? Sine minus sine squared plus cosine squared. Be careful. That's a negative sine squared, so that is not, this is not going to add to 1. That isn't going to work. If that were a plus, I could make it a 1, but I can't. What do I know about cosine squared? Oh shoot, I copied the problem wrong. No, I was looking at it thinking, this isn't going to work. That's a plus. I'm sorry, that's a plus. You would have told me if you'd have been here. So that's sine plus sine squared. Now I got it. That's sine, that's distribute, that's sine plus sine squared plus cosine squared. That's a plus. This makes 1. So on top, I have sine x plus 1. And on the bottom, I have 1 plus sine times cosine. All right, so let's go back to the beginning. This was the original problem. I copied it wrong originally. So I changed tangent into sine over cosine. And then I got a common denominator. So this guy needed 1 plus sine, and this guy needed cosine. So when I distributed, I got sine plus sine squared plus cosine squared. That makes 1. And now I can cancel those, and I have 1 over cosine left. And we know 1 over cosine is secant. Yep, sorry about that. All right. Okay, that takes care of that section. All right, now we're going to do some solving. And you will need a calculator for problem A. I don't think we need a calculator for the other ones, but you will need one for problem A. So we're doing problem A. We're going to do our calculator. And by the way, boys and girls, if we're going to do this problem, we need to have our calculator set in radians, because look at the directions. The directions are 0 to 2 pi, which means I'm in radians. That doesn't change how I do the problem. It's just going to affect my answer. All right, let's look at it. I hope that you see it factors. It's a quadratic. So it's going to be tangent times tangent. And then 4 and 1. I'll put the negative on the 4 and the positive on the 1, so that when I FOIL, my outside and inside make -3. As we've discussed, if that just boggles your brain, you must think of it as x squared minus 3x minus 4. That's what you got. That's the pattern that you have. Instead of x's, you have tan x's. So instead of doing x plus 1, x minus 4, it's tan x plus 1, tan x minus 4. All right, so we're going to set them equal to 0. Tangent is -1, and tangent is 4. This one we don't actually need a calculator for. I want you to think about this for a minute. You have a calculator for the problem, so feel free, you can do it. But this could come in a no calculator problem. If the tangent is a negative number, we have to be over here or down here. Because if the tangent is negative, one of these sides is positive and one is negative. If the tangent is 1, then don't those have to match? And in what kind of angle, what kind of triangle do those sides match? A 45, which in radians is 1/4 of pi, so pi over 4. In a minute, I'll do it decimally with you on the calculator, but this is good practice for us. So now, this is one of my answers. Well, how big would that be? Now look at that now. Remember, this is pi. Wouldn't that red angle be 3 pi over 4, 3/4? And then the blue angle, that's 2 pi. So the blue angle would be 8/4 all the way around, except for that, so 7/4 pi. So if we didn't have a calculator, we could do that problem. That part of the problem anyway. Okay? Now when I'm typing this in on my calculator, I'm going to type in second tangent 1. I'm not going to put the negative in. I'm going to type second tangent 1. And that angle is 0.785. In radians, 0.785. Second tangent 1. I need to know how big that angle is, just like I did here, and then I need to put it in the right quadrant. So here I knew it was pi over 4. Now I know it's 0.785, but I have to put it in the right quadrants. So that 785 has to be in quadrant 2 and quadrant 4. So I need the same angles, but now I'm going to do it differently. This is pi. So that angle will be pi minus 0.785. So that is 2.356. And then, okay, so this is pi minus 0.785. Pi minus 0.785. This one is going to be 2 pi minus 0.785. Which is 5.498. So if I'm doing it with my calculator, I'm going to get those decimal answers. If I'm doing it by hand, I'm going to get the exact answers. And I can do both with this. Not that you have to do both, I just demonstrated both. This one I have to have a calculator for, because this says there's some kind of angle out there that the triangle looks like that. Tangent is 4/1. I don't know. But I know it could happen down here too. Because down here they both be negative, so the tangent would show up positive. I don't know what that angle is. I have no idea. So second tangent 4, it's 1.326. So now I'm figuring out how big is this angle right here? Well, it's 1.326. First quadrant's the first quadrant. And then how about the one in quadrant 3? Now how will I find that one? Remember, this is pi. So how will I find that? Pi plus. So pi plus 1.326 gives me 4.467. So there are the other two answers. So there's 2 from this part, this factor, and there's 2 from this factor. So decimally, there are your 4 answers. Remember, I did that way just so you could see, just so we practice a little bit doing it by hand. All right. Letter B, no calculator, I don't think. No calculator for letter B. And we are doing him in degrees. Not that it matters because I'm not using my calculator. So cosine 2x equals sine x. Boys and girls, we have done at least 3 problems just like this. You cannot do the problem with a 2x in it like that. That ain't gonna work. So we're gonna have to rewrite cosine 2x. So you're looking at your sheet, you have 3 choices. Any of them will work, but the easiest one will be the one that has just signs. So 1 minus 2 sine squared equals sine. Because now the problem is totally sines. So what do we do now? Same thing we did before. We are going to move everything over and get 0. So 2 sine squared plus sine minus 1. I'm adding 2 sine squared. That's already there. And I'm subtracting 1. All right? Let's factor it. Again, if you can't factor that, think of it as 2x squared plus x minus 1. So I'm going to have 2 sine and sine. Got to have a 1 and a 1, just got to figure out which signs are. This will be plus and minus because foiling gives me positive 2, negative 1. So sine x equals 1/2, or sine x equals -1. For this one, I'm going to look at my circle. Where does y, which is sine, equal -1? What angle is that? 270. Now, where does sine equal 1/2? Opposite over hypotenuse. Well, isn't that a 30? So the sine is 1/2 at 30, but it's 1/2 somewhere else. Where else is the sine positive? Isn't it positive over here? So what is the 30-degree angle in quadrant 2? 150. There we go. There are the answers to the problem. I think we may have done that one before. It looks really familiar. Finally, here we go. 4 cosine squared equals 2. Wish you were here to give me your thoughts. I'm thinking about dividing by 2. And then square rooting. So cosine equals plus or minus, when you square root, plus or minus 1 over root 2. Square root of 1, square root of 2. Now I'm going to leave those numbers that way because I recognize those numbers. Don't I have triangles where adjacent is 1 and hypotenuse is root 2? Adjacent over hypotenuse? What kind of angle is that? I'm in radians. What kind of angle is that in radians? It's 45 in degrees, which is pi over 4 in radians. So one of my answers is pi over 4. But wait a minute. This says the cosine could be positive or negative. Well, it's positive over here. Remember, cosine is x. And it's negative over here. So aren't I going to have an answer in every quadrant? Because the cosine could be either positive or negative. So if I have a pi over 4 in every quadrant, what would those angles be? Remember, this is pi, this is 2 pi. So for this one, you're going to do pi, you're going to do 1 minus a fourth. For this one, you're going to do 1 plus a fourth. And for this one, you're going to do 2 minus a fourth. So hopefully, you're coming up with 3 pi over 4, 5 pi over 4, and 7 pi over 4. 1 minus a fourth is 3/4. 1 plus a fourth is 5/4. And 2, which is 8/4, minus a fourth is 7/4. So there are the answers to that one. All right, this one is going to be, this kind of problem is going to be on your quiz. This kind right here. All right, so here we go. Sine u minus v. Sine u, cosine v, minus cosine u, sine v. So, sine of the first, cosine of the second, cosine of the first, sine of the second. Now let's look at our circle. 180 is over here. At 180, the cosine is -1. So this is sine times -1, that's times, minus cosine times the sine of 180, which is 0. Now that's multiplied. Anything times 0 is just 0. So what do I have left? Negative sine x. What did I want to have left? Negative sine x. Part 5, these are the ones we practiced earlier. This will also be on your quiz. Cosine squared plus sine squared. I don't care what that angle is. If it's the same, like it is, 77, cosine squared plus sine squared is going to be 1, period, every time. Now, what about cosine squared minus sine squared? Look on your sheet. That's a formula for the cosine of 2 times the angle, and the angle is 77, so that's a formula for the cosine of 154. Two sine cosine. That's a formula for the sine of 2 times the angle. And the angle is 10. So that's a formula for the sine of 20. Square root 1 minus cosine over 2. 1 minus cosine over 2 square root is a formula for the sine of half of the angle. The angle is 50, so that's a formula for the sine of 25. Tan minus tan over 1 plus tan. That's a formula for the tangent of a u plus v, u minus v. Tan minus tan over 1 plus tan. That's the tangent of 11 minus 3, which is the tangent of 8. And finally, the last one, cosine minus sine. Cosine minus sine is a cosine formula, and it's the formula for the cosine of u plus v. So that's the cosine of 18. All right, 2 more and we'll be done with this. Oh, this one's on your quiz also, this kind of problem. Sine 105, we already practiced it today. Sine 105. Need 2 angles that either add or subtract to 105, 2 angles from my list. I hope you're thinking 60 and 45. That would be the easiest. There are lots of others, but that would certainly be the easiest. All right. U plus V, sine U plus V. That's going to be sine 60 cosine 45 plus cosine 60 sine 45. That's my formula straight off my reference sheet. Sine U plus V. All right, so I'm going to have 4 things again. And the 45s are the same, and they're always root 2 over 2. Now, what about the 60s? Well, you may have that already on your sheet. You may not. I know the sides of a 60 look like that. So sine 60 is root 3 over 2. And cosine 60 is 1/2. I'm going to end up with 1 fraction. the denominator is going to be 4, and the numerator is going to be root 6 plus root 2. And again, every single one of these that we've done, including the one you do on your quiz, is going to be some version of that. Because these are the numbers that we're always using, some combination of those. All right, last one. I want to find the cosine of 2a. Well, wait, before I do anything else, what formula am I going to use? This one is a little bit different because there are 3 versions. And in this problem, it makes 0 difference which version you use. So I'm going to go with the main one, which is cosine squared minus sine squared. But again, you guys, it doesn't make a difference. Do not be confused by that. Pick your own. Pick one. We're going to end up with the same answer. All right, that's step 1. Write down my formula. Now, what do I know? I know that my triangle is in quadrant 3. It just flat out tells me I'm in quadrant 3. And I know the tangent is 3/4. Those are both negative. Opposite and adjacent are both negative. And I'll do the Pythagorean theorem or not. I kind of know this one. If that's 3 and that's 4, the hypotenuse is 5. But if you don't know that, do the Pythagorean theorem. 3 squared plus 4 squared equals c squared. Work it out, you get 5. Remember, the hypotenuse is always positive. These sides, opposite and adjacent, can be negative, but hypotenuse will always be positive. Okay, let's start plugging in numbers. I need cosine squared and I need sine squared. All right, what's the cosine? In that picture, what's the cosine? Negative 4/5. But when I square it, I get 16/25. What's the sine? Opposite over hypotenuse, negative 3/5. But when I square it, I get 9/25. So that negative squares out, that negative squares out. It's a subtraction problem. So 16/25 minus 9/25. The answer to the problem is 7/25. Now, I picked this particular page, the back of page 4. We just did the back of page 4. Because if you have a good command of those problems, the test isn't going to be an issue for you. And the quiz certainly isn't going to be an issue for you. If you don't have a command of those problems, then you need to spend some time this weekend going through it, practicing it, practicing it, practicing it. Okay, that's it, you guys. Thanks for watching. Have a great day.